The next hypothesis test we're going to look at is called the goodness of fit test. With the goodness of fit test, there'll be a claim that the population is divided into several categories based on the proportion that should be in each category, and we'll conduct a survey to see if that actually is the case. The first step of doing a goodness of fit test is to figure out the expected values, or where we expect the respondents to fall if the claim is correct. So this video is going to be about how we find those expected values. And the way we find the expected values is if P is the expected proportion as a decimal from a sample of size n, we expect n times p, that's the formula, n times p, to fall into that category. So, for example, a study claims the proportion of American homes with various number of TV sets is given by so we're going to have a list of the number of TVs, and we're going to say what percent own that number of TVs. So 0 TVs is owned by 10% of the population, 1 TV by 16% of the population, 2 TVs by 55%, 3 by 11%, and more than 3, we'll say 3 plus, is owned by 8%. And what's been done is in a sample of 600 families, how many would you expect to fall in each category? Well, to find the expected amount, let's add another column. The expected amount out of the 600 families. So for the 0 TVs, there were 600 families total. We want 10% to fall into the 0 category. So we will multiply by 10% written as a decimal. Remember, it must always be a decimal. 600 times 0.10, that's going to give us 60. We would expect 60 to own no TVs. We could also take the 600 times the 16%. 600 times 0.16, that's 96. We can take the 600 times the 55%, 0.55, and we find we'd expect there to be 330 to have 2 TVs. We can take the 600 times the 0.11, and we would expect 66 to own 3 TVs. And we could take the 600 times the 8%, which is 0.08, and that would give us 48 respondents who we would expect to own 3 or more TVs. Now that we know the expected number of people that own each number of TVs, we could then run a sample and compare the expected number to the actual results to see if these expected values, these percents, are correct.